Welcome this morning to WINDEV webinar number 5, and today is Thursday, January 5th, 2012, and we have PeteHalsted, and he's going to talk about, was that subject correct? Clarion Queues and the use of associative arrays in WINDEV. Okay, so if you have questions, I guess you can raise your hand, or you don't have the chat, so go ahead. Questions go into the WinDev Skype chat. So, welcome. Go ahead, Pete.
Okay. Well, basically, we've all been stumbling around trying to figure out exactly how to replicate the Clarion queue inside WinDev. WinDev has quite a few different complex variable types, but nothing that 100% matches what the Clarion queues can do. So anyway, I bumped into a project where I needed to use a queue last week, and this is the approach I took. It's not perfect, and we'll get into what the issues are with it as we go along. But depending on what you're trying to do, this is one approach that'll work. We've been discussing some other ideas of approaches that we can try that we'll probably put together demos for in the future, but we'll take you through this demo and go from there. I've put together a little sample WinDev application. First thing is, obviously, you got to declare them. Standard Clarion queue, name, zip code, and age stored in the queue, a string, a decimal, and a long. The way we do it inside of WinDev, all the array types in WinDev only allow one type of variable. In other words, you can have a multi-dimensional array, but they all have to be integers, they all have to be strings. You can't mix variable types. So what we do is we define a structure. The structure is simply a definition of a compound variable type. So we define our structure as having our name as a string, our zip code as a numeric, our age as an integer. Then when we create our array, we create the array of that structure. So as I said, an array can only have one variable type, but a structure is a variable type, so this is an array of structures. Then what the associative array part of it does is define an array that has a key to it. Generally when you're working with arrays, you can only address them by their subscript. The first instance of the record, the second record, the third record. With an associative array, you can define a key, and we'll get into doing that as we go along here. The ignore case and punctuation space is just defining when I create that key, it's going to ignore case and it's going to ignore any punctuation or space as it stores the key. Now let's add some records to the queue. At the top here you'll see the Clarion syntax. And again, I'm not going to spend a lot of time on the Clarion syntax. I'm going to assume that everyone's familiar with queues on the Clarion side. Otherwise, you're not likely to have been interested in this seminar anyway. Then on the WinDev side, we start out with, we have to define a local instance of that structure. The reason for that is some of the commands that work with associative arrays will not work with a global variable. They insist on having a local variable. So that's what this first statement is doing, is just declaring a local instance of the ST customer structure. Then we're just putting the values into the fields. You'll notice I'm using the colon syntax. With WINDEV, we're mainly used to the period syntax. And the period syntax does work for structures, but when I was doing this, I ran into a few spots where it didn't like the period syntax and I had to use the colon syntax. So I just switched over to using the colon syntax everywhere to keep everything clean. Then this statement is where the actual magic takes place. That's our array name. Everything inside the brackets is the key. And then we're just assigning the structure. So this is adding an instance of that structure to our array. And it's keying that array on the value of this variable. Now, one of the interesting things to know is what's inside those brackets. You know, here we're actually using the variable that's also stored in the structure. We don't have to do that. We could actually have put a fixed string here. The key to the array does not have to be at all related to the values that are in the array. I'm not sure where or why you would use it that way, but it's definitely something to keep in the back of your mind that may be a good trick to have in the bag one day. And as far as the question of where's the add, the assignment is the add. If it finds the key, it's going to update the record. If it doesn't find the key, it's going to create a new record. And there's also options when you define the array up there where we're defining to ignore the punctuation and ignore the capitalization. You can also tell it whether or not to allow duplicates. So you can have an associative array with duplicates. And as you loop through and process, you'll see how we handle that. So then all we're doing is adding a second. So we're adding Jones and Smith. All right, so now we have two records in our associative array. Now let's just read through those records. Again, here's the Clarion example of stepping through the records of a queue. In WINDEV, once again, we have to declare a local instance of the structure. And then we just use the for each structure of the customer array. We want to step through it. Now, if you look at the for each syntax on the online help, there are a lot of different syntaxes for the for each. You can actually tell it that you only want to step through the array for ones where the key equals a certain value. So that's another way that you could, if you had duplicates, you could get all the Smiths, things like that. And then we're just using some trace statements so that we know that we got our variables back. And I'll drag the trace window up so everybody can see that. We stepped through, we saw Jones, and we saw Smith. So we're seeing the two records that we added. Okay, now to read one record, more of a direct access, Clarion code up above, WINDEV code again to find the structure locally. Then this ... occurrence, we have to make sure the key exists before we actually issue the assignment statement. If we don't, WINDEV is actually going to generate a runtime error. It does not like you trying to do an assignment with a key that doesn't exist. So that's what ... occurrence does, is it returns a value of how many records match that key. So if it's 0, we're saying Jones doesn't exist. If Jones did exist, then we're moving that instance of the array into our local structure. And then again, we're using trace to see that we got that record. So we should see that it found Jones. And if you see the trace, we did find Jones. I think you could use a partial key when you're doing the for each syntax. I haven't played with that. But the way the for each syntax works, when you start dealing with keys, I believe you could use a partial key there. But for that direct access assignment, you would have to use the entire key. So now to update a record, in Clarion we do a get and then a put. In WINDEV, again, we have to use the dot occurrence to make sure that the key exists. Then we're doing our assignment. So now we've got the Smith instance of that structure out of the array, and we've stored it into our local structure. Now we're going to change the age to 12, and then all we do is the assignment back into the array. And because this key is the same, we're doing an update. Now, this is again very interesting. We could just as easily put quote Jones quote here, and we would be updating a Jones instance of the record, not a Smith instance of the record. So again, the key doesn't have to have anything to do with the actual variable stored in the structure. So now if we run reading all records again, we'll see that Smith is now age 12. Now to delete a record, in Clarion we do a get and a delete. In WINDEV, again, we have to use the dot occurrence to make sure the key exists. If it does, all we do is array delete the array and then the key. So this will delete the Smith instance out of the array. Now if we do reading all records, let me close that trace window so you can see. Now the only one we have is Jones. Now what is the problem with this approach? The problem with this approach is the array is not sorted by that key. And show you that. We've got Jones and Smith, but if I change this to have a Z in front of it, we would still see them in that order because it's showing them in the order we added them. The online help for associative arrays implies that you can use the sort functions and so forth. It's array sort. However, the W language manual says that you cannot do sorts on arrays. I've sent a question into tech support, and my first response was, we can't test every function, send us an example and we'll get back to you. So I'm going to send them this app and show them, but I suspect that the issue is that you just cannot sort associative arrays, which makes the key great for being able to address a particular instance of the array, but it won't let you sort by that. So depending on what you're trying to do, you may need to do sorting. We've been discussing on the board some ideas on how to get that. Most of us feel that memory tables are probably the closest we're going to get to a Clarion array. Problem is you you've got to have a window control for that. So I'm going to play with some of that if I get some time next week. We also talked about data sources. The problem, data sources are really wanting to be defined based on a SQL statement, some type of access to an actual database. So Glenn had indicated that he thought there might be a way around that issue with data sources. So anyway, that's a couple of other approaches that we're going to give a try to in the future, but this is one approach that will get you partway there depending on what you're trying to do. And for me, I was just needing to get several instances of records stored in memory so that I could do some further processing on them. So this approach worked fine for me. I didn't care about the order they were in. So that's the extent of it. Any questions? I'm going to post the links for, I put together a little PDF article. I'll post a link for that and for this sample application as well. In the article, I also show a few additional statements that we didn't get into, that we're doing a little bit of the magic behind the scenes of this thing. Array delete all clears out your array. And I actually think that was one of the only ones that's not shown in the examples. But again, in the article, I do go into that. There are quite a few array functions. I have not gotten into which ones do and don't work with associative arrays. Like I said, array sort was returning an error to me. So I didn't need to use too many functions for what I was trying to do. So there it is. Any questions? I'm not sure what dot each is. I'm doing for each. Like I said, the for each does work. It steps through them, but it steps through them in the order they were added. Now there's a way to, one of the syntaxes lets you add a key after the structure here, then you add the key, and then you define where the key is on this side, and you can get the value of the keys, because remember again, the key doesn't necessarily have to be any of the values that are stored in the array. So you can see the keys, you can tell it to only get keys that match a value. The problem is that it's still going to be in the order that they were added. They won't be sorted that way. Any other questions? All right, well, great. I think we got it, Arnold. If you want to shut down the recording.